Welcome back! Are you watching this immediately? Could you just not wait to learn about variables? Come on, let's get hyped. Variables! Variables! Yeah, let's go! Alright, in this lesson we will be covering different types of variables, very important, independent, dependent, and those annoying confounders. We're going to talk about some research designs like experimental, quasi-experimental, correlational, and descriptive, and then we'll do some examples to test your understanding. Different types of variables! Oh, the variations! First off, what are variables? What is a variable, and what kind of variables need to be considered in research? What do you think? Take a moment to think about what you would say a variable is. Variables, plain and simple, are just things that vary, that can take different values. We measure variables, and this collection of measurements will make up our data. And there are many different things to measure in different ways, so let's start with this example. We could measure how much somebody sweats and how hot it is outside. How do these two variables relate to one another, and how are they different? Take a moment to ask yourself how these two things are similar and different from each other. Let's talk about some Texas heat. Now, when I was making these lessons, I was in a very, very hot, humid room here in Texas. It was so hot, even with the poor air condition blowing as hard as it could, it was still very hot. So, let's say that we want to know how much heat affects how much somebody sweats. You, the researcher, can ask someone to stand outside in the Texas summer heat. That would be kind of mean of you. And we can measure, 1, how much somebody sweats, and we can also measure, 2, how hot it is outside. Now, in this example, which of these two variables that we could measure do you think depends on the other one? Which one's measurement is going to depend on the other one's measurement? So how much you sweat in the Texas heat depends on how hot it is outside. How hot it is outside is completely independent of how much you sweat. Now this may seem like a silly little distinction, but this is vital when it comes to research plans and research design. So we have two types of variables called the independent and dependent variable. Let's focus on the independent for right now. So the independent variable in an experiment is that variable that you as the researcher get to control and manipulate. So you can kind of think of it as the thing with the switch or the dial. So maybe you can turn up the Texas heat, you really can't, but you can put them out into the Texas heat, or you can have them stand directly in the sunlight or in the shade, things like that. In contrast, the dependent variable is the one that depends on the independent variable. This is a variable you are interested in seeing how it responds to that independent variable. This is the thing you're going to measure from a person after you give them a certain drug or after you make them stand in the Texas heat, those kind of things. This is the thing that you measure afterward to see if your drug had an effect, to see how much they sweat, etc. Independent and dependent variables are sometimes also called explanatory and response variables respectively. This is because ideally the independent variable is going to explain the response of that dependent variable. Independent variables are the things that make the dependent variable respond in a certain way. So independent variables are independent of those dependent variables. Now let's go through a few examples. Now I'm going to of course tell you all the answers to these, but take a moment, pause me, and try to answer some of these yourselves. Identify the independent and dependent variable in each one of these examples. Go. Go. Pause me. Give it a try. All right, fine. Ready? Let's go. How about number 1? Eating McDonald's 3 times a day will increase your BMI. So what is causing the other thing? Well, the increase in your BMI depends on the McDonald's 3 times a day. So in this case, your BMI is the response, or that dependent variable, and the McDonald's is the independent variable that explains your increase in BMI. Exercising 30 minutes a day will decrease your weight. This is kind of similar to the last one. Our weight is the thing that depends on how much you exercise and how much you eat, but we'll talk about that later. So in this case, the weight is the dependent variable, and the number of minutes you exercise is the independent variable. About well-being will increase with daily meditation. What is the dependent and independent variable here? Well, daily meditation is the thing that you are doing to hopefully cause a change in well-being. So here, the independent variable is daily meditation, and the dependent variable is your well-being. Next one, metacognition will increase from 4 weeks of journaling. Metacognition is kind of your ability to think about your thinking. Whoa, meta. journal. Journaling's good for you. So how about this one? We have 4 weeks of journaling, and that is supposed to do what? It's supposed to increase this metacognition. So 4 weeks of journaling is the independent variable, and the dependent variable is metacognition. Studying for an hour a day will raise your class grade. So what is dependent on what? Well, we have a class grade here that is going to depend on how much you study and how much effort you put in. So in this case, the dependent variable is your class grade. The independent variable is studying for an hour a day. And lastly, giving multiple independent and dependent variable examples will increase my students' understanding of independent and dependent variables. Is it working? So what is the dependent and independent variable here? Well, I am going to give you a lot of examples, and I am the researcher here. So all of these examples are the independent variable that I am hoping will explain your understanding of independent and dependent variables. So your understanding of that concept, that is the dependent variable. Let's go back to our heat example. So your amount of sweat, that dependent variable, the response to the murder ball up in the sky that is blazing down on us, that's nice and hot, that's the independent variable, the heat from the sun. So we know that your sweating could be affected by the heat from the sun, but what else could maybe be at play here? There might be other things that could increase or decrease how much you're sweating when you're out in the Texas heat. Can you think of any other things that might affect this? So some other things that might be a factor are, what are you wearing while you're standing outside? Are you wearing shorts and a t-shirt? Are you in a bathing suit and actually swimming because you're then in nice cool water? Or are you in a parka for some horrible reason, or in a sweater and a hoodie? Are you in the shade? I mean, it can be many degrees cooler in the shade. Are you engaging in some sort of activity? Like, are you running? Because then, yeah, you're going to be even hotter. And do you have some sort of a thyroid problem or a health issue? That can also affect how much you sweat or don't. These are called confounding variables. Confounding variable is another variable that you didn't account for that might actually affect your dependent variable. So there's other little things that could get in there that are maybe affecting the response from your dependent variable. A confounding variable is also something that can obscure or accentuate, make it bigger, a relationship between an independent and a dependent variable. Now let's look at a few examples. Here is one that I was actually directly involved with. I was helping a research project. We were treating some schizophrenic symptoms. So schizophrenia has positive and negative symptoms. The positive symptoms are literally add-ons, not like positive as in good, as in additional things like hallucinations. There's also negative symptoms, which is kind of the lack of things, like the lack of emotion. So we were trying to treat some of those negative symptoms using transcranial magnetic stimulation, also called TMS. Really interesting stuff, you should look it up. Now, he was coming in about once a week, and there was 2 other researchers and myself, and we would set him up, talk with him a bit, run the experiment, and so on. About 2, 3, 4 weeks later, while we were waiting for the experiment to get set up and I was walking up to the room, he was starting to chat me up, which, great. I mean, he was so kind of flat before, and now it seems like he's trying to reach out. And then he tried to ask me out on a date, which was a little awkward to say the least, so I very politely declined and told the researcher about this, and he was ecstatic. He thought, oh my goodness, this is great, he's responding, look, he's even trying to ask out a girl, and it was all great and exciting. Until we kind of realized, well, is it actually this TMS, this treatment that we've been applying, or is it the fact that there is a nice researcher who is just talking to him and being nice to him, and he gets to do something once a week, and he's coming out and having a nice time, something to do. So in this case, the nice researcher was a bit of a confounder. So who knows? Unfortunately, that research had to be suspended for some other unrelated reasons. It was not me. Let's look at another example. So age and increased income. So we would assume as you get older that your income is going to increase. But is it just because you're aging and getting older? No, because usually as you get older, you have more years of education or maybe more years of experience at your job, and that can lead to the increased income. And the last one, so we have lower education leads to higher chance of incarceration. Now, this is one of the biggest confounders in most social science research, and it's called socioeconomic status. What that means is basically like your parents' education level income, where you're going to school. It has a lot to do with your social environment, your social and economic status and situation. So lower education, somebody who does not have that much education, is typically related with lower socioeconomic status. And that is related to a lot of other things, which then could maybe result in a higher chance of incarceration. But it's not just having a little bit of education, it's all the other things that probably resulted in you getting that lower education that maybe increase your chance of incarceration. So back to our examples. Now let's look through all these again and see if we can find some potential confounders. So pause me again. Take a second. You back? You didn't pause me, did you? Anyway, eating McDonald's 3 times a day will increase your BMI. Well, what if the person was exercising even more times than that? Or what if they were eating salads 3 times a day from McDonald's? Yeah, there's a few different things that could be going on there. But exercising 30 minutes a day will decrease your weight. Well, it also depends on, are they using any sort of performance-enhancing drugs? What is their diet like? Maybe they're trying to actually bulk up and not lose weight, so their weight's not going to go down. Well-being will increase with daily meditation. Well, maybe it's not the daily meditation itself. Maybe it's just the fact that you have set some time aside for you to just have some private time and some quiet time. So maybe it's not actually reciting the mantra or things like that. Maybe it's just having that quiet time. Metacognition will increase from 4 weeks of journaling. Maybe you are also doing some other activities at the same time, like what sparked the 4 weeks of journaling? Are you going to a new therapist who recommended you do that? Therapy's good for you. Are you starting a new antidepressant treatment in addition to the journaling? So if you're doing anything else in addition to the journaling, maybe that's increasing your metacognition. Studying for an hour a day will raise your grade. Well, what kind of studying are you doing? Is it effective? Are you being distracted constantly? Are you really putting in that full hour? Is the class really, really hard? Do you need a lot more time than just an hour every day? And giving multiple independent, dependent variable examples will increase your understanding of IVs and DVs. Well, maybe it will not increase your understanding because you already knew all about IVs and DVs. Or maybe my examples are very confusing and are only going to confuse you more. I hope not. I hope they're working. So the take home is that confounders come in all shapes and sizes, and there's lots of different things that could be actually the reason that something is happening. So you have to stay vigilant and ask yourself, is there some other factor that's not being accounted for in here? Research design! It's really important that we understand some of the basics and fundamentals of research design before we dive into statistics. But I think it's time for a historical moment. This lesson's historical moment is brought to you by Gertrude Cox. Gertrude Mary Cox was an American statistician and the founder of the Department of Experimental Statistics of North Carolina State University, then later a director of the Institute of Statistics, among many other titles. One of her greatest skills was her ability to organize and implement programs focused on teaching others the fundamentals of research and statistics, like what we're trying to do here. She would gather the kind of most important core things that every researcher should know before they go out and practice in the field. She was also considered a statistical frontierswoman. She was a strong advocate for the paramount connection between statistical analysis and the cutting edge of computing. She would totally approve of you all learning R. Because she was so good at communicating the needs and importance for good research design and data analysis, she was well known for being able to secure funding from many different sources. This is a big deal. She also loved traveling, particularly to developing countries, to offer advice, and even helped establish a statistics program at the University of Cairo in Egypt. Her other favorite country was Thailand. And here she is, looking awesome, on a camel, in front of the pyramids and the Sphinx. You go, Gertrude, you go. And now, back to our regularly scheduled programming. Now let's get into this research design. So the first one we're going to look at is called experimental design, or a true experiment. A true experiment involves manipulation of an independent variable. So you as the researcher are going to randomly assign people to groups, and you're going to give one group your experimental drug or treatment, and the other group will maybe be the control group. The second important part of a true experiment is that random assignment. You can't just say, okay, you 5 who I think are going to have a good response to my drug, you go in this group, and you other 5 who I know nothing's going to help you all, I'm going to put you in the control group. No, that's a no-no. You need to randomly assign them, and there's different ways to do this. Experiments are also the main way that we can establish causation. Causation is usually very difficult to establish. You have to control for all those confounding variables to actually say this caused this. Most everything else in research is associations. There are other ways to establish causations with something called causal inference, but that is beyond the scope of this class. There is whole classes on that I recommend you look into in the future. Now let's look at quasi-experimental design. It's very similar to an experiment, but it is knocked down a peg. They still involve independent variables being manipulated, so you might give somebody a drug or a new treatment, but the main difference is that the groups are not randomly assigned. Instead, the groups are already in pre-existing groups, or maybe something about the person is what puts them into a certain group. So for example, 2 classes at the same school, you want to try out a new teaching method in one class, so the other class just has the regular old teaching method. Now this seems very similar again to the experimental, but the students were already assigned into the classes they were in. You did not randomly assign them. They were already in a particular school district, already assigned to their classes. Sometimes causation can be implied, again using things like causal influence, but it's not as strong as a true experimental design. But in many cases, it's unethical or impractical to run a true experiment, so quasi is the next best and still a pretty good alternative. Now let's talk about correlational design. So correlational design is pretty different from an experiment. Now, all you're doing is observing things. There is no manipulation of any independent variable by you. At most, you will just ask somebody their score on something or take a measurement, but you do not manipulate any sort of independent variable. You also need 2 quantitative variables to do this, which we'll talk more about in our next lesson. So you basically observe or ask people questions about 2 things and you see how much those things are related. So, is there an association between the amount of caffeine consumed and course grade? Is there an association between the time in the semester and your level of stress? Yes. And of course, the mantra of all researchers is correlation does not equal causation. It will be said again and again throughout this course. At best, when you do a correlation, you can only say that there is some sort of a relationship or an association between these 2 variables, but you cannot say that one is causing the other one, no matter how strong the correlation. But we'll look more into that when we do correlation later. And lastly, we have some descriptive research, which can be a lot of different things. And here are some examples, like a case study, which is a very interesting medical case that is described in detail by somebody, and it makes for a really interesting story. But the problem with it is that one interesting case usually does not generalize very well to the general population, which is what we want to do many times when we're running experiments and doing research. Next one up is naturalistic observation, which is observing someone or something in their natural habitat. You can kind of think of like Jane Goodall out in the jungle, tracking all the behaviors of those chimpanzees. And lastly, we have surveys, which is just asking a lot of questions. And many times, surveys are really important, so are these observation and case studies, to guide you to getting ready to do maybe a more rigorous full experiment. Testing examples. So let's test your understanding. A researcher is interested in whether a graduate student-taught course improves the student's scores on a final exam over those of students taught by a professor. Students were randomly assigned to one of 2 classes. All right, what do you think? What kind of design do we have? What are the independent and dependent variables? Well, this right here, randomly assigned, should give you a big clue that it's experimental. There's a new type of treatment, which is me, the independent variable, the student teacher versus the professor, and you are going to impose that as the researcher. And the dependent variable would be this final exam. That's the thing we're going to measure afterward to see if they were different from each other. Let's try another one. I'm interested in testing whether group work in class improves test grades. I have 2 classes, one in the morning, one in the evening. I decide to have the morning class do group work, but not the afternoon class. I then compare the average test grades for both classes. What kind of design is this, and what's the independent and dependent variable? In this case, it is a quasi-experimental design because I didn't control which students were in the morning versus the evening class. You all were self-selecting. And the independent variable is that group work. That's like the new treatment I'm trying to give the students. And the dependent variable is that test grade. That's what I'm going to compare afterward to see if group work had any effect. How about this one? Do the number of hours spent studying relate to the level of stress in college students? What kind of design do we have here? In this example, the word relate kind of gave it away. That's an association or relationship, and that's a correlation. I'm just asking people how much they study and how stressed they are. I haven't done any sort of independent variable manipulation. Now here I have independent and dependent variable like in quotes because we can't identify which one is causing the other one. This is a correlation. So technically, the hours that you spend studying could be causing your stress, or your stress could be caused by the number of hours you study or don't study. So there is no directionality here. We're just trying to see if there's a relationship. How about this last one? A researcher is interested in testing whether people with autism perceive shapes and sounds differently than neurotypical people. The researcher administers the Kiki Bobo test and records the responses, then compares them. Now, in case you're not familiar with the Kiki Bobo test, one of these two creatures here, these are creatures from outer space. One is named Bobo, one is named Kiki. Which one do you think is Kiki and which one do you think is Bobo? Now, if you're like most people, like about 95% of people I believe, you probably thought that this was Kiki and this was Bobo. Why? Yeah, science is still trying to figure that out, but they think it has something to do with this sensory binding thing because of this shape here. It kind of sounds like k, k, and this one kind of looks and sounds like buh, buh. Interesting stuff, but that's a different class. Neuroscience. Go look into it. So what kind of design is this? And what are the independent and dependent variables? So here, this is actually just descriptive because there's no manipulation. We're just kind of comparing differences. And we have an independent variable, sort of. It's kind of that autism diagnosis versus neurotypical. These are kind of the grouping variables. And that dependent variable is their response to that Kiki Bobo test. But again, this is descriptive, so there's not really an independent and dependent variable, but you can still kind of think of it in those terms. Now up next, we're going to start looking more into the different types of variables and the different ways to measure them. So up next, variables and measurements. I will see you there.